Hello, I'm Sally Kornbluth, president of MIT, and I'm thrilled to welcome you to this MIT community podcast, Curiosity Unbounded. Since coming to MIT, I've been particularly inspired by talking with members of our faculty who recently earned tenure. Today, my guest is Stephanie Müller. Stephanie is an associate professor with dual appointments in electrical engineering and computer science and in mechanical engineering. Stephanie and her group develop novel fabrication techniques that enable everyday objects to sense and interact with their surroundings in new ways. So, Stephanie, welcome to the show.
Yeah, thanks for having me.
Very fun. So I want to ask you to break down your work a little bit on novel fabrication techniques that help everyday objects interact with the world in new ways. So what does that exactly mean? And can you give us a few examples?
Yeah, so our work in novel fabrication techniques allows us to make lots of very interesting novel types of objects. So one example of this is our work on programmable color. So that actually allows everyday objects to change their appearance on demand.
Okay.
In the same way as, for instance, in digital, you can just use a filter for a photo and it's going to change its appearance. We can do this for physical objects now.
Okay, that is wild. So if I paint my room blue, I can change it to red?
Yes, exactly. And we developed a new material for this. And you simply with one click on an app, you can change the appearance of your entire room to match your daily mood, or if you have an event space like a restaurant, you can also match it the customer who's hosting an event for the day.
So okay, I'm not a data scientist. I'm certainly not a physicist. Can you sort of break this down into a almost lay person term so that our listeners and I can understand how that could possibly happen?
Yes. So we have the smart material is a light activated. So as long as you shine some light on it with specific wavelengths, it can go from transparent to any desired color you would like to have.
I see.
And the light sources we can use are literally any type of light source you can imagine. So it can be just like a flashlight, or it can be a projector to make a specific image. So for the scenario that you described, if you want to change your living room, for instance, to match your daily mood or a certain pattern, we can just mount, for instance, a projector on the ceiling that rotates around, shines some light on the walls, and will reprogram the walls that have the smart material on them.
Amazing. So like if you come down in the morning and your spouse has made the house all like pitch black, you'll know they might not be in a very good mood.
Yes, exactly. Yeah, that's a fantastic way to look at it.
Perfect. So how do you build sort of it's like a generative AI system, I assume, right? From sort of the ground up. Like,
yeah.
How did you think about this and how do you formulate this?
Yeah, so the interesting connection here to generative AI is that generative AI is normally just used for digital items. So you can, for instance, generate an image that's displayed on screen.
Yes.
Or a 3D model that is displayed on a screen and maybe used in an animation movie. But there's typically not a real outlet for generative AI to extend into the physical space.
Yes. Yes.
So with this, you can imagine we actually had a collaboration with a shoe company where we can now use generative AI to sense the environment you're walking in, and we can reprogram the color of your shoe to match that environment. So let's say if I'm going to camouflage it, or if I go to like a after work event, I can have a more colorful shoe. If I go to the office, I can have more like a black professional shoe. So depending on the environment I'm in, the app could, for instance, read from my calendar
that's
where
crazy.
I'm going and what I'm doing. Yes.
That's crazy. It's funny when I think about sort of fabricating things for the environment. I think of like, Star Trek level, like being able to order some food and have it be fabricated.
Yeah,
Is that, I mean, that's obviously science fiction now, but do you see a future like that where people could just, I need a new shirt. Like I could fabricate it in my own home?
Yes, I totally see that happen. So when we talk about like 3D printing, we always think of just plastics and certain very limited types of materials. But the reality is that computer-driven fabrication expands way beyond just 3D printers, right? So if you want to have your shirt made at home, right, there are digital knitting machines, for instance, and weaving machines where you can just send a pattern and they will knit it for you in any size and shape that you basically want to have. So in the end, it just comes down to will we have everything in one magic machine that can make anything that's maybe a little far stretched, or we have certain devices with specific functionality, like you have like a microwave and you have a fridge, right? You wouldn't expect that the fridge can also microwave,
That's
right?
a good point, yes.
It's not going to happen.
Yes.
So the question is just what are these core appliances we will have at home that get the most value for customization?
Oh, I love that. That's great. So do you see all this, are these text prompt systems? In other words, you could see giving a sort of description, I want a blue sweater made of, wool. I mean, is that how you see this kind of thing working, and how does it work, now with what you can do?
Yeah, so the state of art actually right now is still that you have to have some 3D modeling knowledge or some programming knowledge to run these machines.
Yes.
But with generative AI, we are now getting into this. We will have the ability to basically use these types of text prompts. So my group has done some work with something called large language models.
Yes.
You can say, as you said, like I need, for instance, a stand for my iPhone that should look like this beautiful glass mosaic.
Yes.
And it will automatically generate you a stand that will fit your iPhone model, for instance.
That you would then 3D print?
You can then 3D print.
Wow.
Yeah. And it will have exactly this appearance that you desired without any expert knowledge in 3D modeling or anything.
Wow. It's funny because I was visiting a friend this weekend who does carpentry, and he wanted to build a certain kind of table. So he told ChatGPT in words, I want to build this kind of table, et cetera, and got multiple pictures and picked one, and then ChatGPT generated the instructions for making it by hand.
Yes.
So you're talking one step further, not even having to make it.
Yeah. But even the manual work is very interesting in connection with AI.
Yes.
We always think about this when we teach our students, right? Right now they get these manually written out things from the faculty, right?
Yes.
We give them exercises. We're like, you should do this and this and this.
Yes.
But it would be way more interesting to generate something based on the students' individual projects and individual learning challenges that they have, which goes way beyond what the faculty or the teaching assistants can do, because there are only so many of them. We can't tailor every single student in a perfect round-the-clock manner.
Right.
But with these generative AI systems, exactly as you said, they can have these conversations with the generative AI to help them get specific support for their projects.
Yeah, very interesting. So do you think this is do you see this as a sort of beginning of moving away from mass production? Do you think, if you were to look, 20 years down the line, 30 years down the line, do you think that the landscape is going to be very, very different? And, thinking about how that would scale, and I'm just curious.
Yeah, so I personally think that everything will be personalized in the future. If you think very, very far back in time, this is actually how it was when everything was handmade. You would go to the person making the shoe, right? And they would customize it for you. But then obviously that was only accessible to people who had a lot of money, right? And with mass manufacturing, now everybody has access to this. I always compare it to the digital domain, right? In digital, there's nothing standardized anymore, right? Like if you go to Google or some other search engine, right? Everything is personalized. Every single website you use is customized to you.
Right, that's right.
And in the physical domain, we still largely use standardized, we can choose, but only from very specific categories. Right. I think that will go away and will be replaced with personalized items.
It's interesting because this really parallels, obviously. I'm a cancer biologist by training, and it really parallels what's going on in medicine and medical treatment. The tension between being able to just mass scale things and the really individually tailored therapeutics that I think will get less expensive and more accessible with time.
And the individually tailored is obviously always better and more desirable. Right?
For the individual.
For the individual, exactly.
Yeah. So if you think about sustainability, how do you think about industry and this sort of mode of manufacturing on sort of, our environment and sustainability?
Yeah, so sustainability is a huge challenge, and it is a very complex question to discuss. I think you can look at it from many different angles. I think one interesting angle in psychology, they have actually shown that if something is made specifically for you, you are actually holding onto the item much longer.
Oh,
than
interesting.
If it's like just something
and taking better care of it,
taking better care of it because it's really what you wanted. It's very personalized, and maybe you spend some time in personalizing it by going through the interface and so on, which is very different from, just clicking grabbing something from a rack and then throwing it out with fast fashion is especially bad at the moment.
Right.
Obviously, then there's the other side of it, which is the manufacturing side, right? How's this gonna change the whole mass manufacturing? Because obviously, if you can inject mold 1,000 parts in one mold, that's more energy efficient and other things than if you make it personalized for the individual.
Yes.
But it's a very complex question because with 3D printing and other things, you save assembly, you save storage of parts, you save shipping of parts across the world. So it is a huge topic with many different aspects to it.
Oh, very interesting. It's interesting coming back to the medical applications. Could you imagine this being, we have folks like Hugh Hare who work on prosthetics, et cetera. Do you see this? Someone can get customized prosthetics, and maybe that's not that far away.
Yeah, so I think medicine is actually one of the early applications for personalization with physical objects. And it can go as far as really making something functional, like a personalized prosthetics that's 3D printed. Those already exist in parts, not the whole prosthetic, but individual segments. But it can be as small as even just helping people with some accessibility needs to get items that work better for them.
Right.
So for instance, we have one project where we can use these text inputs where somebody just describes something to customize objects not only with the look but also with how they feel.
Yes.
So we just generated for somebody, they needed like a custom like walking aid, and they wanted to have something with like better grip for their hands. And they could just verbalize, I wanted to feel more like rubber, I want to have it more like a rocky surface, so I know it's like this part versus this, because maybe they couldn't see quite well. And with generative AI, we can not only generate those models like visually and the shape, but we can also generate the tactile feel on them.
So. You know, on a really common and maybe even somewhat trivial example is, I think about right-handed versus left-handed usage. I've met people who are left-handed surgeons, for instance, who say their learning curve is longer with standard instruments. You know, or you think back to like third grade, the poor left-handed kids with the right-handed scissors, etc. You know, that's a trivial example, but I can imagine. So how did you actually become interested in 3D printing technology?
A lot of people think 3D printing is a very new technology. It's maybe 10 years or maybe 20 years old. But the reality is it was actually invented in like the 70s, 80s, around that time. Back then, these were like giant machines, a bit like with the first computers, right? They were like also giant machines. Only big companies had access to it, right? It was very hard to get your fingers on. Everything was closed source.
Yes.
And in like the mid 2000, like 2008, around this time, the first like low-cost 3D printers came out. And this is when I started my PhD. So I was like, oh, now there's actually a way to get your hands on these machines and to tinker with them, add some hardware to it, write some code. So I was just there at the right moment in time when this technology became more available.
Oh, interesting.
So in my research field, I was one of the first people who actually developed like new ways to use these machines to make new types of objects. And now they are so widely available, right? And people have them at home. Every university has them, right? Libraries have them. Kids in, elementary school already know what a 3D printer is.
Yes.
So it's just very interesting how much the technology became available in the last 20 years. And
Although I still think it's a little bit daunting for the average person.
Yes, that's right.
In other words, so this notion of a ChatGPT-like interface, as opposed to actually having to know how to code or operate the printer. Right, I think there's still a little bit of a gulf there.
Yes, that's right. Yeah, and that's actually one of the very interesting things with generative AI. Has this potential to lower this entry barrier because you can just describe what you want.
Yes.
But a lot of these generative AI models, they have only been made for like on-screen content. So it's actually really funny if you tell generative AI right now, I want to make a chair.
Yes.
They will generate you the model, but if you actually print it out and you sit on it, it might actually break. It might actually break, because generative AI is like, look, it looks great.
Right.
And you're like, okay, but how can I tell you that I actually want to sit on it? It should take this weight and so on.
Yes.
So generative AI systems, they don't have any notion of this because they are typically trained on images.
Yes. Oh, that's interesting.
Yeah.
So you're thinking then that these programs are going to have to be supplied with a lot more information on real-world use in some way.
Exactly, yeah. And that's actually one of the key focus like our lab works on right now, is to supply this extra physics-based information, right?
Yes.
So we have like projects both on making sure that things don't break when you actually use them, right?
Yes.
We actually generated like a pair of glasses, and normally they would break in the middle just if they are generated based on images.
Yes.
But we feed the generative AI system with some mechanical simulation. So that the simulator can actually say like, hey, when you make this shape here, this is too thin, it's going to break. Can you make it a little thicker the next round? And then if you print out those glasses with the 3D printer, now they're actually sturdy and they won't like break the first time you drop them on the floor.
This, I mean, has the potential to be huge upheaval in a lot of different industries then.
Yes, for sure.
I mean, I think about, just shopping for glasses and trying to find the right thing. But if you could really tailor it to your own face and pick your colors and
yes, exactly.
Very interesting.
Yeah. So I think the whole personalization aspect is huge, right? again, just like also not generating waste, right? By making sure it really fits you, right?
Exactly.
I can't even tell you like how often I discarded something because after like using it for a week or two, I realized, oh, it's not fitting right, or it's uncomfortable, right?
Yeah,
but if it's really perfectly made for your face, for instance, or for your foot, if you have a shoe, those issues will hopefully not happen.
That's
anymore.
crazy. Very fun. So I'm wondering about sort of thinking about who you would partner with in further development. I don't know how you think about commercialization of all this, but, things like safety and, fire, police, et cetera, things that are bright, things that change colors to reflect sunlight, things that can be cooler or hotter depending on weather for people who have to be working outside, et cetera. So can you, how do you think about the sort of partnerships and commercialization that might allow these things to move forward in all these different realms?
Yeah, so that's very interesting for us because we typically, as you said, like who's going to be interested in this technology, right? It's very hard for you to say if you're in research because you're doing the research, but what we know very little about what industry exactly needs. Right?
Exactly.
So for me, it's always very helpful when we do a podcast like this, or we have an MIT News article, right? Then actually a lot of companies see our work and then they reach out to us.
Oh, really?
And
That's
like,
great.
Hey, we just saw this. Can we have a collaboration on this? Maybe they already have a program with MIT, or they want to create like a new collaboration. So we have seen like lots of different companies reach out to us, and then all of these interesting questions come up, like how does the technology survive like a whole manufacturing cycle when it's integrated in the specific product? What are some regulations? Once you bring it on the road, right? For instance, for our color changing technology, we worked with a car company. And one of the applications was actually depending on the background, like let's say it's brighter or darker outside, or depending on the background you're driving in, how can we highlight the car so that other people can see you better?
Oh, that's interesting.
Yeah. But then what does this mean? What if there's some failure in the technology, right?
Yeah, that's right. The car becomes invisible,
into the environment, right? So there's lots of different questions related to this.
That's really good. So you were a student at the Hasso-Plattner Institute in Germany, and now you're partnering with them on a project studying sustainable practices, including design solutions to waste reduction. So can you tell us a little bit about that?
Yeah, so there's this wonderful collaboration with the Hasso-Plattner Institute MIT program. It's organized from the Morningside Academy of Design. And what I'm really excited about is that we use generative AI here on a material level. I already talked about using generative AI to, maybe ensure that objects don't break and so on. But that's really more on like a function level. So the goal here is, let's say you have recycled material, which again comes back to sustainability and waste. Recycled materials are typically not quite as great as new materials, right? Because when they get broken down and let's say plastics, right, they get melted. Let's say they have less structural strength, they can take less weight, for instance. So what we're doing is we are teaching the generative AI model what types of materials are going to be used in manufacturing. And then the generative AI, for instance, will create a design that can work even with this like slightly weaker material.
Oh, interesting.
So it's still going to be exactly personalized to you, and it's still going to be a desirable design, but it might just look like a little bit different by reshaping certain parts to be more structurally sturdy.
Oh, that's really interesting. So are you glad to be working with colleagues in your native Germany?
Yes. It's nice to speak some German.
Yeah, that's nice. That's nice. So I'm just wondering how the MIT environment in general sort of enables your work.
So MIT is a fantastic environment, and literally the work I'm doing right now I can only do because I'm at MIT. And that's just a wonderful thing to say and just to be aware of for myself as well. I traditionally come from a program that was basically computer science only. So we had like really, really strong computer science people, and we built like really amazing software systems. But just being in this environment where I have access to mechanical engineers and people working in optics and materials and this whole like melting pot of different colleagues' ideas is really just a fantastic place to be.
There's just really amazing things going on. And so finally, so what do you do when you're not working?
When I'm not working, so right now I'm in a very specific stage of my life. I have like two small kids. I have a newborn baby and a toddler. So I know
what you're doing.
my time and my love goes to taking care of them. before that, otherwise, I'm like a huge activity and travel fan. So I love to do all sorts of like sailing and sports. And once the kids are grown up a little bit, I hope to travel again a lot. And that's great also if you're faculty, right? There's so many international programs you can collaborate with. So I look forward to going back to that stage.
Yes,
that I was
great.
When I was a junior faculty. I traveled a lot. And now it's a little bit on hold, and I hope to go back to this.
I'll eventually get back to that stage of life.
I hope so, yeah.
Fantastic. Well, I really enjoyed talking with you and learning a new area that honestly I did not know anything about.
Yeah, thanks for having me.
Very eye-opening. And to our audience, thanks again for listening to Curiosity Unbounded. And I very much hope you all will join us again. I'm Sally Kornbluth. Stay curious.